Unit 2 review, go! Which shows a function? A function cannot have repeating x's. This table has repeating -3s, giving me different outputs. No. This mapping, the 2, is giving me 2 different outputs. No. The ordered pairs, zeros, giving me a 20 as an output here, as a 9. They repeat. No. This guy passes the vertical line test. There are no points stacked immediately on top of one another. All the x's produce a different y. This one's good. And the y equals x, just start asking yourself, what if x was 2? Y would be the same thing. One input is giving one output. Is there any way 2 can produce another answer from this equation? The answer is no. 2 is the only thing that x will produce. What if it was a 5? Y would be equal. If it was -3, it would be -3. One input is producing one output. This one's good. The answer is D. Next one, you see an equation. What do you do with an equation? That's right, put it in your calculator. So I have it in my calculator all ready to go. I noticed in that word domain, those are the x's. That means that these are all the x's. Where do I find xy table? Second graph. And I go find x is -2, and it wants the solution set, so that means that it's the range. Remember, if you're given the equation and inputs, that means that all of these guys over here are outputs. So I'm looking in the y column, and notice that the first y output for an input of -2 is -12.5. The only answer that has a -12.5 is C. Number 3. We're going to box this snake-looking thing up, and we're going to look on the y-axis because that's range. So I highlight, I'm going from 0 to 4, and I'm using the letter y. So that's not using the letter y. That one's not going from -4 to 0. So it's these two. Let's check the dots. At a low value, I have a closed dot, so I'm equal to -4. Those are the same. I shouldn't really check that. Up here at 0, I have an open dot over here. If I slide over here, walk down the street, there's an open manhole cover right there. But right here, at this point, there's a closed one. We go with the closed. I can be equal to 0 at this point, so I'm going to be equal to 0. We pick D. Next one right here, we're looking for the range. So I highlighted the y-axis. It goes from 0 to 144. Okay, no, 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 no. These are the only two that go from 0 to 144. And if I go from 144 up here to the very tippy top, I see that that is a closed dot. I can touch this graph right here, so I'm equal to y equals 144. I pick F. The next one, over here, which one is not true? Make sure you read the problem. The y-intercept is 0, 180. That is true. The x-intercept, or 0, is 0, 6. That's false. That's the one I want. This point right here is 6, 0. They have it backward. The other two answers are true. Number 6. This is where you need to just think a little bit, and I bet you can get it. When you're doing a problem like this, you read the problem and you go, hey, I have a perimeter that can't go over 75. So my maximum perimeter is 75. If all the sides are the same, 75 divided by 3, that means that the maximum each side could be is 25. So if you notice over here, this answer maxes out at 25, this one maxes out at 25, that one maxes out at 25. All real numbers, ladies and gentlemen. Right now, all real numbers for you are all of the positive and negative numbers that you currently know. Positive, negative fractions, decimals, percents, mixed numbers, improper fractions, integers, 0, I mean, everything that you know, that's all real numbers. So this is going to go higher than 25, because I know numbers bigger than 25. This also includes negative numbers, and my sides can't be negative. So let's get rid of that right away. Now, let's think. Can I have a side that's negative? The answer is no. Okay, can I have a side of 0? No. Okay, so the smallest one that I could have is some number that's positive, that's greater than 0. So I don't care what it is. It could be microscopic. It could be 0.1 on each side, and that perimeter is still less than 75. But I can't have a side of 0, and I can't have negatives. Okay? So this one, this is all of the numbers less than 25. This includes negatives. Sorry. All right? Now, so it's down between these two. This one is a discrete. This means that there are only 25 possible triangles. This is saying I could have a side of 1. Okay, that works. Or I could have a side of 2 on each of these. Remember, it's equilateral. But my question is, can I have a side that is, I don't know, a 24.5 on each side? Is that possible? Is that real life? Can I have 24.5 on each of these sides and still be less than 75? The answer is yes. Does this set include 24.5? Do you see it? Is it listed? No, it's not. So this one includes 24.5. And it also includes the 0.1 that I mentioned earlier. This is all of the numbers, all of the different possibilities that I could have. This is the one I want. Okay. Next one. This is, people are still messing up on this type of problem here. What you need to do is you need to start with your first 2 x's and your first 2 y's. So that's why I put a little box around here. Because it varies directly, I know I have 0, 0. My next x and y are 4.5 and 19, so we stop. A lot of y'all are putting in this 66.5 right here, and it's throwing you off. So right now, just use 0, 0, and the first x and y that you see. What's your rate of change? Delta y over delta x. It's 19 over 4.5. Pick up your calculator and hit math, enter, enter, and you get this funny rate of change, 38 over 9. What do we do with our slope or rate of change? We write an equation. So now my equation, using my slope, produces this equation. Okay? So now, this is a y value. So I'm going to plug in 66.5 in for the y. How does that look? It looks like this. This is the final equation that will get me what I want. So I'm going to have to divide both sides by the number in front of the variable. So I'm going to have to divide by 38 over 9. Both sides. Well, that looks weird, but your calculator can handle it. I got to divide 66.5. So here we go. Take a calculator, try this. 66.5 divided by. And now I want you to do something new, at least for my classes. I want you to press alpha y equals, alpha y equals, alpha y equals, enter. And you notice it gives me a fraction template. That's cool. What's my fraction? 38 over 9. 38, tab out of that, 9, arrow out of that, and now press enter. Your answer, x is 15.75. All right, next problem, number 8. We're given a bean bag toss game. I have rows with the number of holes in each row. I just get that from reading the problem. I see equations, and I know that with a calculator, we can put it in our y equal button. Ladies and gentlemen, this has a rate of change of 3. This is a rate of change of 3. This has a rate of change of 4. Don't pick it. This has a rate of change of 3. This has a rate of change of 4. This has a rate of change of 3. Now, just put these in your calculator, test them out, and here we go. Y equals, and I'm going to type in 3x minus 1, and I'm going to go to my table, and I'm going to scroll to what row? I want to scroll to 20. 20 is 59, which is right here. 59 is my answer for row 20. Pick D. If you do this for the other answer choices, you will not get the proper answer. It won't match up. This equation will not give you 59 in your table. This equation will not get you 45 in this equation. And well, that's the wrong answer anyway. How am I doing? All right. So, sequence, rate of change. Sequences, rate of change is easy. Just how's it changing? It's changing by 5. That has a slope of 4. That has a slope of 1. That has a slope of 4. The only one that has a slope of 5 is C. That's your answer. If you're not sure, pick up your calculator. You have an equation. It's a funny looking equation. It's an arithmetic sequence, but just say, I'm going to type in 5x plus 1. Second graph, sequences always start with what? Sequences start with 1. All right, there's my 9, 14, 19, 24, blah, blah, blah. Next one over here, guess what? You have an equation. So you should type this thing in. You're given an equation. What else are you given? You're given an x value, that's an input. So if you're given an equation and the input, these have to be outputs. So I'm going to be looking in the y column. So know what you're doing before you start looking at stuff on your calculator. So let's see how quickly I can type this in. Negative, what is it? Negative 16, parentheses, x minus 4, close the parentheses, and we're going to square that. Square button is right here, square button. And then make sure you add the 255. If you leave off the 255, you will lose. All right, so my input, I want an input. See, it says x equals. It's very clear. X equals 7. When x is 7, my y is 111. Pick that one. The next problem, okay, this is a parabola. It's half a McDonald's arch. What attribute or characteristic? So does this point right here, is that my x-intercept? Well, no, it's not even close. Is that my y-intercept? Is it on the y-axis? No. Okay. Actually, this one has two answers. It's both the vertex and the maximum. In this curve called a parabola, at the very top or bottom, in this case it's the top, this is called the vertex. You might want to write this down. You're going to see it on your test. And because it's on the top of a mountain, it's a maximum. Okay? If this were a smiley face like this would still be a vertex, but it would not be at the top of the mountain. It would be at the bottom of a valley. This would be called a minimum. All right? Next one, domain. I have 1, 2, 3, 4, 5. This is discrete, so I should have 5 members of my domain. Domain is x. So what's the x? I have one x value here. I have another here. I have another here. Another here. 1, 2, 3, 4, 5, 6. Listed out is C. Over here, the 0 on number 13. I want to keep going down 1 and right 1 because that's my slope. Down 1 and right 1. I continue on. Down 1 and not right. Start over. I'm saying the wrong thing. Down 1, left 2. Down 1, left 2. Down 1, left 2. Down 1, left 2 is this point right here. This is my 0, and that is negative 8. And the last one over here, we take a look at this. If I blow this up a little bit, okay, you might be able to see it. So I'm domain, so I'm going left to right. That's why I have my x-axis highlighted. And this has a low of negative 2 and a high of 7. And you got to be able to realize that the way that they worded this, okay, again, it says all real numbers. Don't worry about that. That's all the numbers that you know. Greater than negative 2. Well, my highlighting is bigger than negative 2, so that takes care of that. And less than or equal to 7. That's a closed dot, and it's below 7. That's why we're going to pick A.